In this video, we're going to talk about factoring polynomials, and we're going to start with just the very basic way of factoring with a common monomial. Now, monomial, just as review, means a polynomial with only one term. So if I think about the polynomial 6 plus x, well, 6 and x are not like terms. We can't combine them, so they are their own terms, and so 6 plus x is two terms, so that would be a binomial. Monomial means there's only one, so 6 itself is a monomial, x itself is a monomial, 12a to the 5th, b to the 7th is a monomial. So we're going to say, or look at, how can we take out a monomial, or sometimes we call it a greatest common factor, out of an expression or equation. And we have to remember that factoring is just the opposite of distributing. There's a lot of things in math we do that are opposites. So if you can think about distributing, you should be able to factor pretty easily. And the reason we would want to factor out a common monomial, the main reason is just to simplify what's given. There are some other reasons why we might use it, but simplifying is the main reason. So first, let's talk about just some of the key things to look at. Now, this might be review. If you're looking at some higher level factoring, you can probably skim through this video or just skip it. But again, these are just kind of the basics of factoring. So anytime we see an expression or an equation, we want to figure out, can we simplify it at all? No matter what we're doing with it, we always want to simplify what's given. So we're trying to find that greatest common factor. We're always going to start with the coefficients, or at least I do. So that's that number that's in front of the variables. And I always look at the smallest one and think if it's a multiple of the other coefficients. So can you take all the coefficients and divide them by the smallest one we see? And then with each variable, I like to go alphabetical, and I look for the smallest exponent in each one to help figure out our greatest common factor. And as always, we want to check our answers. So if you need to check, the opposite of factoring, as we said, is distributing. So you just distribute what you found and see if that gives you your original equation or expression. So we're just going to quick look at distributing here. If we have 6 times x plus 3, we know, let's go red here, we know we're just going to distribute this 6 in, do 6 times x and 6 times 3, and that gives us 6x plus 18. So what we're going to be given is a polynomial similar to this, and we want to go backwards and say, is there anything we can factor out of all of the terms given here and pull it out front here, and then we figure out what's left on the inside of the parentheses. Okay? So first example, 4x to the third plus 12x to the second power. So we have another binomial, just two terms here. Start with coefficients, so we look at the 4 and the 12, and like I said before, kind of the easiest way for me to think about it is, can the smaller one go into the large one? Can we take 12 divided by 4? Since 4 is a multiple of 12, we can factor 4 out of both of those. Okay, so we're going to factor a 4 out front. And both terms have an x, so we know we can take an x out, but we got to figure out what is the exponent of this x that we're factoring out of our two terms. So that's where we look for the smallest exponent. X to the third, that's the same as x times x times x. X squared is the same as x times x, so they both have two x's that they're multiplying in their terms, and 2 is the smallest exponent, so we're taking out a squared, and now we got to figure out what's left on the inside. And some people like to take the terms in their polynomials and almost set it up like a fraction, so they divide this term by 4x squared and this term by 4x squared to see what's left inside. Well, we know distributing is multiplying, and since distributing and factoring are opposites, well, factoring is basically dividing a term out. So that's where that dividing comes in. So we end up with x plus 3 once we factor the 4x squared out of each of these terms. And again, if you were to distribute and multiply 4x squared back into the parentheses, you should get what we started with. One more quick example here. We've got a little longer polynomial here and a couple variables. So I'm going to start with my coefficients as always, 15, 30, and 25. And I notice they all end in a 0 or a 5, so they all should be at least multiples of 5. But I'm going to see if there's anything bigger that goes in. 15 is our smallest coefficient. And we can do 30 divided by 15, but we can't do 25 divided by 15 without getting a decimal. So we can't factor 15 out of everything. We can only factor a 5. So we got that 5 there. And you might see this negative here and think about factoring out a negative. You could factor out a negative. That could make it more simplified, but a lot of times it just makes it messier when we are dealing with negatives there. So unless every term is negative, we probably don't want to factor out a negative. So this term is going to stay negative. They all have an a. So again, I look at the smallest exponent. We got a 5 and a 2 and 6. So we can factor out a squared out of each of those three terms. And they all have a b, and we've got 3, 3, and 2. So we can factor out b squared out of each. So that's our greatest common factor, that common monomial we're pulling out front. And now we can just divide each of these terms by 5a squared b squared. Again, you can kind of take each term and divide. I like to think about, if I were distributing, what would I multiply this by to get this term? Well, I know 5 times negative 3 is negative 15. So we're going to have that negative 3 there. A to the second times a to what power is going to give me a to the fifth? Well, I know from exponents that an a times another a, we have to add the exponents. So 2 plus 3 would be 5. So a squared times a to the third would give me a to the fifth. And then for b, we have b squared here and b to the third. Remember, that's b times b here, b times b times b. So if we multiply this by another b, that would give us b cubed. So we get b cubed for the, or just b, excuse me, for the first term. And then when we divide each of these by this this common factor here, we end up with 6b. 5 times 6 is 30. We already pulled out the entire a variable here, a squared, so there's no a left in here. And then b cubed, similar to that first term, b squared times a b will give us b cubed, so we have 6b here. And then we can't forget this negative, so negative 25 divided by 5. Well, that should be a negative 5 here. And then a squared times a to the fourth would give us a to the 6, because 2 plus 4 gives us 6. And we factored out a b squared out of here, so there's no more b's left, so we're not going to have a b variable in this term here.